All right, in this video we're going to talk about reaction mechanisms, catalysts, and rate determining step. So reaction mechanisms are just the steps that a reaction is going to go through between forming our products from our reactants. So a reaction isn't going to just happen quickly or just kind of instantly. It's going to go through a series of steps. And in those steps, we're going to form what are called intermediates. They're not going to be our final products, and they're not going to stick around for long, but they're going to be formed in the transition from reactants to products. So in reaction mechanisms, so this reaction has three separate mechanisms. And we have our mechanism 1, 2, and 3. So first of all, our rate determining step is going to be our slowest mechanism. So number 2 is going to be our rate determining step. It's like if you run a relay. Your fastest time is only going to be as fast as your slowest runner. Same with reactions. Our reactions are only going to go as fast as their slowest step. So the rate determining step, the one that determines the overall rate of the reaction, is going to be the slowest mechanism. So in this case, our rate determining mechanism, our rate determining step is number 2. And for our catalysts are substances that are going to lower our activation energy and alter the mechanism pathway, but aren't going to be consumed or used up in the reaction. So they're going to be something that is going to be present in our initial reactants and in our final products unchanged. So in our mechanisms, our very first set of reactants are our initial reactants. And then our very last set of products are our final products. So as we can see here, it's the H that remains unchanged between our initial reactants and our final products. So H, or hydrogen, is the catalyst. And so to demonstrate how this reaction mechanism may work, or how these mechanisms work and what the actual reaction is, what we can do is we can actually cancel out our intermediaries, or cancel out everything that occurs both on the product side and the reaction side. So very similar to Hess's law. So first of all, I can actually cancel out my H's, because I have an H on my product side, or I'm sorry, an H on my reactant side and an H on my product side. I can also get rid of my HCO, because I have an HCO on my reactant side and on my product side. And that is all that I have that duplicates. So the equation, or the overall reaction that I'm left with, is, oops, nope, sorry, there's one more. I missed HCOOH2. Sorry about that. So the overall reaction that I'm left with is actually, now that I've canceled all of my intermediates, so everything that I've crossed out was my intermediates, except my H was my catalyst. So I've crossed out my catalyst and my intermediates. So all that I have left is HCOOH as my reactant, which is going to form CO plus H2O. And notice we didn't include hydrogen in our reactants simply because it's a catalyst. We've added it to the reaction only to reduce the activation energy and speed up the rate of the reaction. So it really doesn't play any other role in the reaction other than to decrease the activation energy. So we don't write it in our reaction equation.